Hey there, science fans! Have you heard about quantum computers? They're making waves in the science community and beyond. Imagine a computer so powerful it could solve problems in minutes that would take classical computers billions of years. That's the promise of quantum computing. It's like upgrading from a bicycle to a spaceship. Quantum computers are not just faster versions of the computers we use every day. They operate on entirely different principles, harnessing the mind-boggling world of quantum mechanics. This field of physics studies the super tiny world of atoms and the particles within them. It's a realm where things behave very differently than in our everyday experience. The excitement surrounding quantum computing is palpable. Scientists and engineers believe it has the potential to revolutionize fields like medicine, material science, artificial intelligence, and more. Imagine developing life-saving drugs with incredible speed, creating entirely new materials with unheard-of properties, or understanding the human brain like never before. We're on the cusp of a new era in computing, one that could dramatically reshape our world. Buckle up because the future is looking quantum. Okay, so how do these quantum computers work their magic? Well, to understand that, we need to compare them to the computers we use every day, which we call classical computers. Think of a classical computer like a light switch. It can be either on or off, representing 1 or 0. These ones and zeros, called bits, are the basic units of information in classical computing. Everything your computer does, from browsing the internet to playing games, is based on these bits being flipped on or off in different combinations. Now imagine a special kind of light switch that can be not just on or off, but also in a mixture of both states simultaneously. That's kind of what a qubit is like. A qubit is the basic unit of information in a quantum computer. Unlike a bit, which can be either 0 or 1, a qubit can be 0, 1, or a combination of both at the same time. This mind-bending ability of qubits to exist in multiple states at once is called superposition. It's like a coin spinning in the air before landing on heads or tails. It's both heads and tails at the same time until it settles down. Superposition is one of the key secrets behind the immense power of quantum computers. Let's dive a bit deeper into the fascinating world of qubits. Imagine a spinning coin again. The coin's state is whether it's heads or tails. In a quantum computer, a qubit state is a bit more abstract. It's like a knob that can be turned to different angles, representing different values. These values are not just limited to 0 or 1 like in classical bits. A qubit can be in a state that's partially 0 and partially 1 at the same time. It's like our spinning coin being slightly tilted. Not entirely heads or tails, but a mix of both. This mix is the essence of superposition. It allows a single qubit to hold much more information than a classical bit. As we add more qubits, the number of possible states they can represent grows exponentially, giving quantum computers their incredible computational power. Think of it like juggling. One ball is easy, but as you add more balls, the number of possible juggling patterns explodes. Similarly, more qubits mean exponentially more possible states, allowing quantum computers to tackle incredibly complex problems. Section 4. Entanglement, spooky action at a distance. But wait, there's more. Qubits have another trick up their sleeve: entanglement. This bizarre quantum phenomenon links 2 or more qubits in a way that even Albert Einstein found spooky. Imagine you have 2 entangled coins. When you flip them, they always land on the same side, even if they're miles apart. It's as if they're secretly communicating with each other, instantly knowing what the other is doing. Entanglement in quantum computing is similar. When 2 qubits are entangled, their fates are intertwined. Measuring the state of one qubit instantly tells you the state of the other, no matter how far apart they are. It's like having 2 knobs linked together. Turning one instantly turns the other in the same way. This spooky action at a distance, as Einstein called it, is another key ingredient in the power of quantum computers. Entanglement allows them to perform computations in a fundamentally different and much faster way than classical computers. Section 5. Real-world wonders, from medicine to materials. So what can we actually do with these mind-bending quantum computers? The possibilities are incredibly exciting. Drug discovery. Imagine designing new drugs and therapies with incredible speed and precision. Quantum computers could simulate the behavior of molecules with unprecedented accuracy, helping us develop life-saving medications for diseases like cancer and Alzheimer's. Materials science. Quantum computers could help us design entirely new materials with tailored properties, like super strong but lightweight materials for cars and airplanes, or incredibly efficient solar panels for clean energy. Financial modeling, quantum computers could revolutionize financial modeling, making predictions about market trends with greater accuracy and helping manage risk more effectively. Cryptography quantum computers could break the encryption codes we currently use to secure our online data. But on the flip side, they could also help us create even more secure encryption methods to protect our privacy. These are just a few examples of the potential real-world applications of quantum computing. As the technology advances, we can expect to see even more groundbreaking uses emerge, transforming various industries and aspects of our lives. Section 6. Challenges and limitations. A road under construction. Now, it's important to remember that quantum computing is still in its early stages of development. It's like a road under construction. We're still paving the way and overcoming significant challenges. One of the biggest challenges is building and maintaining stable qubits. Qubits are extremely fragile and sensitive to their environment. Even the slightest disturbance, like a tiny change in temperature or vibration, can cause them to lose their quantum properties, a phenomenon called decoherence. Another challenge is scaling up the number of qubits in a quantum computer. Building a quantum computer with millions or billions of qubits, which is necessary for solving some of the most complex problems, is a daunting engineering feat. Furthermore, writing algorithms or sets of instructions for quantum computers is a new and complex field. We need to develop entirely new ways of thinking about and programming these machines to fully harness their potential. Section 7. A bright quantum future. Despite these challenges, the future of quantum computing is incredibly bright. Scientists and engineers around the world are making remarkable progress in overcoming these hurdles. New qubit technologies are emerging, offering greater stability and scalability. Error correction techniques are being developed to mitigate the effects of decoherence. And the field of quantum software is rapidly advancing, with new algorithms being designed for specific applications. It's an exciting time to be following the quantum computing revolution. While it might be some time before we have powerful, general-purpose quantum computers, the journey itself is filled with incredible scientific discoveries and technological breakthroughs. So, stay curious, keep exploring, and who knows, maybe one day, you'll be the one making groundbreaking discoveries in the amazing world of quantum computing.